Okay, for your last lab for this course, we are going to cover the topic of ANOVA, or analysis of variance. And just as a quick reminder, analysis of variance is similar in many ways to an independent samples t-test, but is used in the specific cases in which you have more than two groups. As you recall with the t-test, if you have more than two groups, you can only compare. Let's say you had three groups. You could compare group 1 to 2, group 2 to 3, group 1 to 3, but all in separate analyses. Whereas with ANOVA, if you have more than two, so you have 3, 4, whatever groups, you can run ANOVA to tell you are there significant differences between those groups, and then break it down even further to see if there is a significant difference, where that exists, between which pairs of groups or independent samples that those differences exist. So again, we're going to use this familiar data set, and I'm just going to show you how to do this. So for ANOVA, in this case, I'm going to be interested in, I'm going to use class, so freshman, sophomore, junior, senior, so there's 4 groups, and I'm going to look at the variable of just test 1. I'm just going to use that as to see if by class, if there's a significant difference on performance in test 1. So I'm going to go back to analyze in the same spot where our t-test was, compare means, and go down to one-way ANOVA. And then, again, you get a box that looks like this. Our dependent variable, in this case, we're interested in test 1. And then factor simply means what is the grouping variable. And in this case, we're grouping by year in school. So we'll just put that in there. As it talks about in the material and in your book, there's a couple things we need to look at. So once we need to tell SPSS not only to run the ANOVA, but then also once the ANOVA is run, which looks at all the groups together, to look at whether, again, there's differences between individual pairings of groups. And we only really do that if our overall ANOVA is significant. So I will show you that in just a minute. So that's called post hoc testing, so things that we want to look at after we look at the ANOVA. So we click on that box. And as it outlines in your chapter, we want to select the Tukey is generally for equal variances, and then we can use this Games-Howell post hoc comparison for in situations when equal variances are not assumed. You hit continue, and then also if you actually not that button, I wanted to click the options button here. So the options button, you'll get a pop-up that looks like this, and I'm going to click descriptives. And again, as it talks about in your book, there's a couple assumptions when you run an ANOVA. One is that your variables are normally distributed, or the outcome dependent variable is normally distributed, which again, we learned how to do that way back in the earlier labs. But also there has to be a homogeneity of variance. So I'm going to click that button, and these 2 other tests that we use if this condition is not met. Again, this is all outlined in the chapter on ANOVA in the textbook. So I'm going to hit continue again. Okay, so we get our descriptive. So again, and we have a very small, obviously, group of freshmen here. So we have all 4 of our groups, the mean, score, and standard deviation for each of those, and then some other data. This is the test of homogeneity of variances. So based on the mean, in this case, this is below 0.05. So this is significant. So that there's not a homogeneity of variances. So we've violated that assumption in this case, which means we can't use our regular ANOVA printout. We have to go down and use what's called these robust tests. So either the Welch or the Brown-Forsyth, which again, you can see similar to our ANOVA results, these are not significant. So what does this mean? This means when you compare this test 1 between those 4 groups, there is no significant difference that exists between the groups. So in that case, you can be done. You don't have to go any further. Had this been significant, we would then go down to our post hoc test, and we would look, and you can see in this case, we have what's the difference between freshman, sophomore, freshman, junior, freshman, senior, and we would go over, and one of these, or more than one of these, would actually show significance if our overall ANOVA for the groups was significant. We would find maybe the difference between sophomore and freshman was where the difference is, and that would be significant. Obviously, in this case, none of them are, but that's just the example. So you run that, you get your descriptives. If the homogeneity of variances, if this was above 0.05, we would just simply use this output with our F statistic and our significance, and we would just stop there. We would say something to the effect of An ANOVA was run to see if there was a significant difference on test 1 between freshman, sophomore, junior, and senior, or between class rank. The results of the ANOVA showed that there was not a significant difference in the means of scores across freshmen, sophomore, juniors, and seniors.